We're going to do problem 9.43 using the reciprocal method right now, and I'm going to demo the whole problem just to show you about how fast it happens. It's maybe a bit tedious, but there are a couple of places in the problem where it's good to see the logical flow in the order of the flow. That's one reason I do problems in class. You know, when you look at the solution, you just see the flat solution, and it's not clear what the sequence of steps to get the solution were. And especially in the when you're learning how to do this, the sequence often is a very important part of what you're doing. So here I go. We did the direct and step methods for problem 9.43. I will be typing and writing at the same time, so I'm sure I will screw this up because typing and talking, not my skill set, as you know. So here we go. First, I need to go through several steps to get the data in. When you're doing it in a spreadsheet, you have to get the data entered and get that set up before you can actually do the reciprocal method. So first I'll set that up. I don't know why I do this, but I never use the top corner, the A1 cell. I always drop down a few because somehow my past experience tells me something else will need to happen up there. Factory administration, factory maintenance, cafeteria. Okay, and what we have is, remember, we're setting up data at first, so we have the direct labor cost, we have the direct material cost, we have the overhead costs, and we can total that. Okay, so I'll type that in. And made a mistake. Direct material cost was factory admin did not have any direct material cost, and made the exact same mistake on the next line. Overhead cost. Now this is a little bit tricky because the two production departments have overhead. And the three service departments have overhead. That is their own internal overhead. And we have to be a little tricky later because in the later parts of the problem, everything here is that I've highlighted is actually overhead for the production departments, even though when you only look at the administration department, they have direct costs plus overhead. So this then can be a bit of a problem. I'm not going to total that right now, but one thing it would be handy is to come up with the overhead in each department. Okay. Notice to do that, I'm just going to use cell references for the first two. But for the second, I'm going to do a sum. I'm going to move out here. One quick way to do sums over ranges is to use the sum formula like I did, then use the cursor or the mouse to move out. Because I'm an old guy, I always use the cursor. Then when you get to this cell, hit the colon, so shift colon, and that places sort of an anchor at that cell, and then when you move up with the cursor or the mouse, it'll pick up the rest of the cells. You can do the same thing and with the mouse easier. However, with experience you'll tend to use the cursor more because to use the mouse you have to take your hands off the keyboard, which definitely slows you down. And I'll copy these across. So that's actually the overhead for the company as a whole, and we will need that later. The next thing we need to do is look at the other data because we have other pieces of data that we need in the problem. they all have to be used properly. I will change the spacing up here just a bit so that it looks a little bit nicer. So we need the number of direct labor hours. So 56250. And you can tell I actually wasn't looking at what I was doing. I was looking down at the keys. Okay. Let me verify if those are the right numbers. Yep. Number of employees, 280, 200, 12, 8, 20. Okay. Square feet. Okay, now we've got the data entered roughly. With one manipulation, this row is a subtotal that we computed because of our knowledge of accounting. So we know that these are production departments, and so we just take their internal overhead, and we know that these three departments are service departments, so their total cost will be considered overhead later in the problem. Okay. Next thing we need to do is, you'll see that even when I do my own spreadsheets, I do many of the things I ask you to do in the spreadsheet assignment, which is I do everything step by step by step. So this next step, probably most people would do it inside a formula on a different step, but I've found that through time, the ability to come back and explain your logic to someone or check and see if your logic was correct is so important that I do everything step by step. So next thing I want to do is remove the values from the departments that we will be transferring out of. Remember, we are transferring costs out of the service departments. Okay, so I need to create a little matrix here of the things I'm going to remove. They're going to be based on the input categories, so direct labor hours, number of employees in square feet. But I need to say which ones of these are going to be transferred out. So I'm going to do that by using 100% or a blank. Okay, so by putting a 1 here, I'm saying, no, I'm keeping 100% of those numbers in all cases. But here I'm not. I'm going to skip. That one is going to stay blank. I'll color it yellow so you can see it. Because that is the factory administration, and I'm going to be transferring out of factory administration based on direct labor hours. But it stays, whoops, went too far. But I'm not going to be transferring out based on number of employees in square feet. So for factory maintenance, I'm going to be transferring out based on the number of square feet, so I'm going to leave that blank. And for the cafeteria, I'm going to be transferring out based on the number of employees. So I am just creating this because I can use it to multiply and delete the factory maintenance direct labor hours, factory administration direct labor hours, delete the factory maintenance direct labor hours, and delete the cafeteria. In the next step, I'm going to do a multiplication based on that little matrix. And if you multiply by 1, you just bring in the same number. If you multiply by nothing, then you don't bring that number in the next time. So So when you do the missing values, you need to do this. So I'm bringing in the same items, and this is just a multiplication. So equals this times this, but I can't use that by itself. I have to, or actually no, this one can work because we're multiplying each matrix by each matrix. So I can copy this one down. And notice what I have now is I have just got zeros for the transfer out portion, but I didn't do it manually. The thing you could do, and the beginner you would often do, is you would just type this in and then just manually just delete this because you're not going to use it later. Okay, but then you haven't left a record of what your logic is. So by having this step here, you're leaving a record of your logic. Now if you were doing this professionally, you would come up with a better explanation here. The spreadsheet I'm doing right now will not be used again, and so I'm describing what you would say, what the purpose of this little matrix is. Okay, now we actually have the pieces we're starting to need to do some multiplication. The next step that we need to work on is to multiply this out, okay? Because we need to turn this matrix here into a set of percentages. So to do that, we actually need to know what the denominator is. So we need a sum across here. And then we'll take this entire thing and do the division. So we're going to come over here, recreate the structure. Okay. And right here, equal this divided by this. Okay. Here's where we need to come back and make that an absolute reference. Some people would hit F4. I don't do that. I think it's bad programming because you actually don't need to lock in the 24. In fact, you don't want to. You only want to lock in the column. You want to let it be able to paste down correctly. So that now still has the correct number. I can Control C to copy, and I can paste across. Then up here I can grab that formula, copy it down, and I have a check figure. So I've summed across. Guess what? The sum of the percentages has to equal 100%. So that's a little check, and so that means that I did do that multiplication correctly. That is a good step. So let me check one thing quickly. Just 1 second. Then we go to the next step. We have those. This is what we need, is those percentages to set up the next matrix. You'll notice that the one I have posted is on the web is in a different order. In fact, when you're doing the reciprocal method, the order really doesn't matter. So right now in this example, I'm following the way the data is laid out in the textbook pretty closely to make that a little easier to follow. This next step is the matrix to invert. So this is the key setup, and it's not a matrix, it's a matrix. So setting this matrix up is the next important step. We need to have all of the departments identified. So I always do it this way. So I don't retype, but I copy. And the next one is a bit of a drag because you have to copy it down one at a time. So equal. Notice this is, because the layout is not the same, we aren't able to copy and paste. So we don't have the advantage of really what Excel can do because we are going to data that's in two different orientations. Now we need to, now this is the tricky part, okay? This is sort of the magic of the whole thing, which is we're going to create a diagonal here with numbers in it. This is how we impose our accounting logic on this whole system. So if you took this, what I'm going to show you, all these spreadsheets, to like a math professor, they'd follow the math. But this part, they would say, why are you doing this? What is the purpose here? What we're going to do is we're going to introduce purpose into this. And notice, this is a step that you have to do. It doesn't come from the numbers. It comes from your knowledge. What we're doing here is, in this matrix, we're transferring money out of the service departments and into the production departments. So that one, the plus one, is our in, means add 100%. The minus one means delete or subtract 100%. So we're going to add 100% of the overhead costs into the production departments, and we're going to take out 100%. So this is the piece that makes this whole thing work. Now we have to go back and assign percentages. So remember, we're going to do fabrication and assembly first. What gets transferred out of fabrication? Nothing. So these are all the transfers out and in. So we're transferring nothing out. So we're transferring nothing from fabrication to assembly, nothing. Fabrication to admin, nothing. Fabrication to maintenance, nothing. So we put zeros in these two. These are the production departments. Over here, we're going to have to copy in those percentages that we just took a look at. So from factory administration, we are transferring to fabrication based on direct labor hours. So we need to pick up that one. Direct labor hours, we need to pick up that one. And to maintenance, direct labor hours, so we need to pick up ups. And I made a logical mistake here. We're transferring to maintenance, so I need to go up to this one. And then I forgot to do the cafeteria line. So you can see that this is not a perfect system if you have operator error here. So we have the cafeteria also needs this. And we're transferring from administration to the cafeteria based on direct labor hours. So notice this has to be done manually. Then we're going to go to factory maintenance. We transferred from factory maintenance to fabrication based on the number of square feet. So we have to go pick up the number of square feet. We have to go pick up the number of square feet. Have to go pick up the number of square feet in administration. And then we have to pick up the number of square feet in the cafeteria. Notice we don't pick up the square feet for maintenance to maintenance. Now we go to cafeteria. That's based on the number of employees. So we go and pick up number of employees, number of employees, number of employees, and number of employees. And somehow, did I get this off a bit? Maintenance, number of employees, 0.124. Yes, I missed one. So I went too far here. Let's delete this one. We have to do number of employees from maintenance, or from factory administration, and then here from maintenance. So I got out of order while I was talking, as we knew I would. So then here would be the last step. Okay, first we need to then invert this. So we have to create the space to invert this. So this is the data that we have. So this matrix is our data at this point. Now we have to invert it, and we have to create a place to put the answer. So we need to first come down here and create the answer spot by creating the structure. I will do this again, Control V to get that. Then we'll come down here and copy this structure down. And in here we have to do the following. Watch what I do. I'm holding the Shift key down and I'm highlighting this area. So I'm creating a place for an array we're going to be using what's called an array command, called minverse. When you have an array command, you have to create the place for the answer to go. Notice in this matrix, the top left cell is white. The idea is when I start typing now the command, it's going to be put into that top cell and then propagated throughout all the other cells. So now, look at the top of the screen. I'm going to type in the command. It's going to appear in the top left cell, equal minverse open parent. Now notice it's prompting you and saying what array do you want to invert. So now I have to use my cursor or my mouse and go and tell it where the data is. So I'm going to come up here and highlight the data. Notice that the data and the output area have to be the same size. This is the only reason this works. So inverting a matrix in Excel only works with a square matrix, meaning when the number of rows and columns are the same. And guess what? That means it's magical for us for this purpose, because when you're transferring from departments and to other departments, the number of departments that you're in the from and the to are always the same. So you will always have a square matrix, meaning that Excel can always do this. The next thing you have to do, I wish I could show you, but in fact I'm doing it on my keyboard. I'll tell you what I'm doing. There are 3 keys that you have to hit at the same time. Or you can do the first 2 and then hit the third one. What you have to do is hold down Control Shift, 2 keys at the same time, and keep them down, and then you have to hit the Enter or Return key and then let go of all 3 at the same time. So I have now depressed Control Shift and I'm hitting Enter and letting go. That executes an array command. As if you start doing more technical stuff with Excel, you'll see that there are a lot of array commands that work really effectively, especially for these kind of tight, small analyses. This then is actually the answer. It's the inverted matrix. You will never be able to do this on an exam. So on an exam, I might ask you to prepare this matrix. Okay? But I would never ask you to do this matrix. Okay? Next thing we need to do is actually figure out the costs. So we have to multiply these matrices. Remember, we computed a cost up there at the top. I'm going to go up and grab it. So remember, we had computed this. I'm going to copy it here just so we can see it. In fact, you don't have to copy it. You could do the next step just doing cell references back up to the top. But since we're just learning, it's handy that we see them again. So what I need to do is create the cost matrix, and this is the last step. So I'm going to create the structure so that we can see it. Okay. There we go. Then what we need to do is do the multiplication. So we basically have to multiply this vector by this matrix. Okay, so equals this times this. If you drag this across now, you'll get a bunch of garbage. I'll show you. Control C to copy it, Control V to paste. And that's because if you look at the formulas, that one's sort of updating okay, but notice when you drop down, C46, times C52, if you look, there's nothing in C52. So you get all these crazy values. And then the next one is actually multiplying by C53. So what you have to do is come back here and freeze this row. Once again, some people try and freeze the whole thing. Basically, in this case, though, what we want to freeze is just that row indicator. If we take this and copy it and paste it now across, we will get the correct answers. If we sum across on the side, and only necessary to sum these two, this is actually the total. I'm going to copy this down. For more advanced analysis, if you sum these 3, you'll get some numbers that have some interpretation, but that's well beyond what we're doing here. We're just doing the accounting for overhead analysis. So for the financial accounting purposes that we have, these are the numbers. That is the actual overhead that we will total transfer to fabrication. This is the amount of overhead that we will transfer into the assembly department. So this then is the end of the problem. Notice it's several steps long, but also take a look at this. This is like the magic thing that I think is so cool. Notice that this number was 199. If we go back up to the top, so next year you use the same sheet and you have different numbers here. Remember, these numbers are just typed in. So I'm going to change this to a big number. Remember that answer down there was 191,000 or 1,900,000. Notice that actually this changed to 49 and 252. So this is live. This is a great spreadsheet to keep using, because once you get it refined, you never have to duplicate all this stuff down here. With a lot of other Excel functions like regression, you have to rerun the thing every time. This one though, you can completely change and reuse every period, because any changes you make in this area will be propagated correctly through the entire system. So this actually, you know what, if you know how to do this, this is the one you should be doing. The one exception is you will have some people, if they haven't gone to university recently, trust me, you're not going to be able to explain what an inverted matrix is to someone that hasn't taken some university math courses, and that could be a big stopping point. That's the only weakness of this method, is explainability of this matrix is a little bit weak, or actually quite a bit weak for people that don't have a good math understanding. And if it throws them off, if they're uncomfortable, probably just not worth the effort. But notice, and actually this is even a little bit easier to do than the other methods, even though it's actually a much more sophisticated method, and the math is perfect. So this is the perfect cross allocations. It's not the perfect economics, because none of this stuff is right. You guys know, especially after your work term, every accounting number is flawed in some way. So all these inputs are a bit flawed, so that means the answer is not perfectly economically correct, but it is the perfect mathematical assignment based on our inputs. And actually, I should draw this a little bit bigger. It's not just these numbers that are wrong. Even our definition of what the departments are, we know, is not perfectly correct. And our categorization of the costs, we know, is not perfectly correct. So that's why the economics of this is not the correct economics, because our inputs are wrong in every way. Definition of departments, definition of costs, and then the values even that go under them. But you know what? It's pretty good, and it's the best we can do. So that's problem 9.43 in the reciprocal version, and you should practice that, take a look at it. I would definitely ask you on an exam to get up to this point. Okay? I would definitely not ever ask you to do this. However, I would give you this and have you, if I give you this, I would expect you to be able to create this. Okay? Well, that's it. Problem 9.43, you've now seen 3 different methods to do it. Bye-bye.